Because it's Merca? Okay. Why do you assume it's not metric? Oh, it's A. It can't be metric, huh? A for no, it's M for Merca. All right, so we'll say feet. Make yourself happy. So if that's what I write, if I don't give you units, you get to choose whatever you want. The only difference is the constant you multiply by, whether it's 62.5 or 9,800, 9,800. So, gee, I keep forgetting what to do here.
X and Y, yeah.
Oh, good idea. Where do you want to put them?
Right in the middle.
You want the x-axis right in the middle? Put the x-axis at the bottom.
Yeah.
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 And let's put the y-axis in the middle. Take advantage of the symmetry. Right? This is definitely not a constant sort of x width. So we definitely want to take advantage of symmetry if we can. Well, having written that, I know right away I'm going to integrate from 0 to h. And it's going to be 62.5 times length times width times height of a typical box, right? Typical column of water. So I'm going to go somewhere on the y-axis from 0 to h and grab a little strip. How thick is that strip? Infinitely thin. It's so thin you can't see it, right? Which is why I'm drawing this big thick line. Make sure you think of that as infinitely thin. So that is dy. And we'll turn it on its side here. All right, there's that darkened little strip. That's the dy stuff. That's how tall that infinitely thin line is. Well, let's label this point, since it's in the first quadrant, xy. Now we know that it is a width of 2x. And the height looks like h minus y, doesn't it? So 2x, h minus y, dy. H is just a constant that will stay in there. 2x, well, that needs to be established. We have to see the relationship between x and y, and then use that to substitute for x.
Why is the height 8.5?
Because having labeled this point y, that means that this distance is y, but this distance is h. So what's left over? That's how deep that strip is under the water.
Well, you have to find the equation of that line.
What line?
The line with that point is x1.
It's not polite to point.
Sorry.
No, you're not. But he's right. Let's get the equation of that. Well, what's that point?
A.
1/2 a, comma 0. And what are the coordinates of that point? Comma h. So we have to get the equation of the line using those 2 points. The slope, it might be easier to just calculate this one. H minus 0 over a minus 1/2 a. So that's h divided by a over 2, so that's 2h over a. And again, the a and the h don't bother us because they're just constants that will be supplied at a later date. The equation of the line now, it's probably easiest to use this point. It's got a 0 in it, so y minus 0 equals the slope times x minus the x coordinate. So if I multiply that out, actually I'm trying to solve for x, aren't I? So I might as well multiply by a over 2h. All right, no point in simplifying the line in the traditional manner because that would solve for y. So if I do this, I get a over 2h times y equals x minus 1/2 a. And so x is 1/2 a plus a over 2h times y. And I don't know, you may want to get a common denominator. You may want to factor the 1/2 a out, but however you write it, I would probably do that. Factor out the a over 2. Then I'd be left with 1 plus 1 over h times y. But it doesn't matter. You can certainly leave it the way it's written right here. And that's what you're going to do there. In place of x, you're going to write 1/2 a plus a over 2h y. And multiply the thing out and have a lot of fun plugging in the h. Plug the h out of it. Or into it. Oh, hell yeah, 10 of them. All 10.
So the distance or the height of the strip, it's from the top of the water, not the top of the object.
Correct.
So if the object went
Because we're
over-
trying to see how much water is above that strip.
Okay.
So of course it'd go to the top of the water.
And then so let's say the object was above the water, the
That would be
distance
portions.
would be.
Quit taking pictures of her, that's no fair. She ain't signing no release.
The water level would be the height and then the 0 to the
If
h
it were
would
a
be the
portion
object.
above the water, whatever was above the water, we would ignore. Would not become part of the problem. Questions? Filming her. All right, 31. 31. Yes?
But in this case, we did from 0 to 8, right? Not from 0 to 11.
Right, because there's no plate up here to accumulate weights for. Right, we go from the bottom of the plate to the top of the plate, but up here, there's no plate to exhibit any, to experience any pressure or force. Questions? 31. 31. Find the centroid. Y equals, I did 31 yesterday, right? So let's ignore that. 33 we did not do though. X plus y equal 2 and x equal y squared. And we're supposed to find the centroid of the region bounded by those curves. And this is 33. Well, do we need to draw it? I guess, sorta. I mean, x equal y squared, we know that that's a parabola that opens this way. What's the slope of that line, positive or negative? Negative, very good. So that line's got to go through it somewhere like that. Right?
Yeah.
So we're in a little bit of trouble here, depending on exactly what it looks like. Maybe we'll get lucky and we won't have to worry about two different functions here. Maybe they'll have it go through more like that, where you've got this little tiny strip. Now you only have one function on top. But those are our possibilities. How am I going to discover what this thing looks like?
Set them equal to each other. Find an
Find points of
intersection.
Yeah. Yeah, if I integrate dy, then it's not going to matter, is it? So, well, it will, because we'll have to set up our integral. So no matter what, we still want to get an idea of what it looks like. Let's substitute in. Let's replace x with y squared. So instead of x plus y equal 2, I'll have y squared plus y minus 2 equals 0, which is y plus 2 times y minus 1, I think. Is that right? So y equals negative 2, y equals positive 1. So x equal y squared when y is 0, x is 0. If y is plus 1 or minus 1, then x is 1. If y is 2 or minus 2, then x is 4, right? And I think we just found the points of intersection as well. After all, when y is negative 2, that must be this point. And when y is positive 1, that must be this point. So now what? Following Patrick's suggestion is probably the easiest thing to do, but I don't have to do that. I could find the centroid for this using the formulas that we've been given, and then I could find the centroid for this, and then consider those 2 points to a finite number of points, and I could find the centroid in the fashion that we did before. Well, that'd be a lot of fun and a lot of work. What was Patrick's suggestion? Somebody other than Patrick.
Do a dy integral.
Do a dy integral, right? Because then you got one function on top, one function on bottom. So did the book suggest that we ever think about that somewhere? So, me expecting you guys to read the book, is that kind of like the dreams that occur when a guy is smoking opium? Is that it? It's called a pipe dream? I believe that they did an example like that, didn't they? No, they didn't do it on example. They did not do an example like that, so you're off the hook on this one.
There,
But
you
I
see?
know-
You see?
Yeah, but they discussed it. And remember, I saw it in there. Where do they tell you how to do that? Well, they don't. Oh, I bet they do somewhere. Somewhere between 602 and 603. That's all right. We don't need their stinking formulas. Because we'll make them ourselves. What were those formulas? X bar is what?
1 over A.
All right. Well, so we'll say the area of the region on bottom.
And x
Integral A to B.
of
X, f of x, dx, or if there's two curves, then we get the integral from a to b, x, and f of x minus g of x. Well, these are the ones we really want, aren't they? The second one, because after all, that's clearly got two curves there. So that's where you've got y equal f of x, right? How's it going to change if you have x equals f of y? Well, now it's not going to be x bar that you're finding, it's going to be y bar, and it's going to be the integral, let's say, from c to d, and it's going to be y, f of y, minus g of y, dy, divided by the area. Wait a minute, no, this is when you've got functions of x. This is what the book gave us. This is a new situation. This is where they didn't give us functions of x, the blasted devils. They gave us functions of y. Oh, it just means swap x and y around. That's what we do, right? I mean, think about it this way. How about this? How about if instead of finding the centroid of that region, what if I were to interchange x and y there, and interchange x and y here? Oh, that's the same thing. I could find the centroid of that region, and then switch x and y back again. And if I do that, I get to use the formulas that the book gave. Then I don't even have to think, but that's the same thing as not switching x and y and switching x and y in these formulas. So let's do that, and then we'll just switch x and y back again. Yeah,
That's supposed to be X bar, though, right? Where you go, Y.
no, I want to switch x and y around.
Oh, okay.
So that's why not only did these x's switch for y's, but so did that. Okay, so let's not do that because the book didn't give you those formulas, and that's going to be a trifle more confusing, I think, maybe than just doing what we've really been trained to do. You've been trained to do that. You may not realize it, but when you were finding inverse functions, your teacher may not have told you that what you're doing is a 90-degree rotation. That's what happens. Right, so let's look at, well, of course, wasn't that convenient when you interchange x and y? Nothing happened. So let's look at our new functions, x plus y equal 2 and y equal x squared. So now, well, do I really need to intersect them? Don't I already know what the points of intersection are going to be? What are they going to be? What are they going to be? What's negative 2? X is going to be negative 2, and x is equal to 1, right? Because now I'm not going to substitute in place of x, I'm substituting in place of y. Instead of x plus y equal 2, I've got x plus x squared equal 2. Notice it's the exact same situation we had, but we're just interchanging x's and y. So I'm going to get x equal negative 2, x equal 1. And y equal x squared, well, we know all about that. At 0, we get 0. At both 1 and minus 1 in x, we get positive 1 for y. And at both positive and negative 2 for x, we get 4 for y. Well, let's see. When x is negative 2, we're talking this point. No, this point. And when x is positive 1, we're talking this point. So notice we're looking at exactly the same region. It's just been inverted. So how do I find now the centroid of that? Yeah. And what are they? X bar equal integral from minus 2 to 1.
X.
Let's see, the line's on top, so x times
X plus
2 minus x, very good, minus
square.
dx.
Over here, yeah.
Is that right? What was that formula for x bar? Well, I'm not done yet over the area, but the x bar formula was integral a to b x f minus g, right? And now because we're considering the y-axis, well, no, we're not doing that. We're normal integral, right? Lines on top. And the area, integral from minus 2 to 1.
That's minus.
The same thing, but without the x. And y bar, integral minus 2 to 1, and it's going to be 1/2 2 minus x quantity squared minus x squared squared, or x to the 4th. And then that also is going to be divided by the area. And I won't write the integral again, because as soon as we find the area there. And then when I'm done, I will just switch x and y back again. And I'll have the centroid of the region desired. And I didn't have to invent new formulas this way. So I can leave this, right? I mean, these are simple integrals to do, polynomials. But don't forget to switch x and y back again at the end.
So after you find these, then what you meant was your X bar will actually be your Y bar.
Exactly. So you guys realize that the class is more than half over now. After today, we only have 11 more times together.